All right, so we got, we're actually, in the book now. This is your 1-1 homework. I'll do about half of it. This is number 3. Find the key features of this graph that you're given. Its domain, it goes from -4 to +4. However, you can't actually put your pencil on -4 because there's a hole there. So we're going to use parentheses. There's nothing there. Seems kind of funny, but you can see a nice solid dot at 4. Somebody filled that in with a pencil. Range, I see a low y value of -1 and a high y value of 3. And these points do exist. If they didn't exist, there'd be a hole there. So -1 to 3. Oh, and if you like set builder, you could do something like this. This needs to be talked about. All values of x such that -4 is less than x is less than or equal to 4. And off the range, if you like range, all values of y such that y is literally stuck, and these are equality symbols, less than or equal to -1 and 3. X-intercepts, those are where you cross the x-axis. There is one back here at -3, 0. There's one right here at -1, 0. O for origin, by the way, and there's one over here at 4, 0. I put problems like these on basics quizzes. I can't remember what number they show up, but it amazes me how many kids can't find an x-axis. Y-intercept's going to be right there. Looks to be at 0, 1. Intervals where the graph is positive. You're positive if you're above the x-axis. So I'm going to go ahead and outline everywhere I'm above the x-axis. I'm above the x-axis here, here, and there. And then I start talking about the values of x that make this true. I'm above the x-axis between -4 and 3, not including 3, because at 3 I'm on the x-axis. So from -4 to 3. Now we also have this word union, which basically means and, or. Also from between 1 and 4. And you look at your x values. All right, now where am I negative? I'm negative in just one little region of territory here. There. That's where I'm negative. I'm negative so long as the x value, sorry, I'm losing my voice here. I'm negative so long as the x value is between -3 and -1. All right, where am I decreasing? Decreasing means negative slope. Downhill. A lot of kids struggle with negative slope for some odd reason. It just means downhill. I mean, that's what I remember being taught in like 6th grade. Oh, I'm going downhill. Oh, I read a graph left to right. I think that's what some of those problem is. You read in a non-standard way. You read from right to left when you're supposed to read from left to right. So I see some negative slope here and I see some negative slope there. My slope is negative for x values between -4 and -1. And union with 2 to 4. Increasing means positive slope, which is going to be your uphill. This region of territory has my uphill slope. So that's going to be from, that's supposed to be -2, isn't it? Okay, -4 to -2 over here. Sorry. That's going to be from -2 to +2. Now, the reason we're not using brackets is because here there is no slope. There's no slope. All right, then we have the rate of change on the interval from -1 to 4. So what I'm going to do is I'm going to go where x is -1, which is right here, and then I'm going to go to 4 by connecting the line. Because slope is, a linear concept. And this is a line with no slope. So the average rate of change is going to be, the abbreviated average rate of change, ARC, is 0. There's number 3. I think the next one I've got in here is the fun one. Yeah, you're supposed to sketch a graph with the following key features. So the domain is from -4 to 4. And notice the parentheses. What I'm going to do is I'm just going to kind of put some dashed lines here from -4 to 4. Had one of those had a bracket, I would have done a solid line. But notice these mean open hole. The range is from -4 to 6. Notice that one is open and this is closed. So I'm drawing in this little box that I've kind of outlined here. We are increasing from -4 to 1. Here's the big ones. These are things I need. I have x-intercepts at -2, 0 and 3, 0. I have a y-intercept at 0, 4. Those are the easy ones. Whoops, too far. I want that. And let's take a look at all the other stuff. It says that we are increasing from -4 to +1. -4 to +1. Which means we're going uphill. And I'm also looking over here, so as I'm negative from -4 to -2. This means I'm below the x-axis. And I'm thinking about this, increasing. And this thing had a domain of -4, a range of -4. So I'm just going to put an open hole here. And it looks like I'm going to increase. I'm going to be negative all the way to where x is from -4 to -2. So at -2, I've got to be crossing that x-axis. And I increase until the x value hits 1. You see where it says I increase until the x value hits 1? So we're just going to go uphill. And because I have this nice solidity on the 6, I'm going to make it a little steeper so I can run into that 6. And that is increasing all the way to 1. I'm going to put a nice solid dot up there too because I had a bracket there. So I must be touching that point. I am decreasing from 1 to 4. So I'm looking at this. And I'm also looking at this where I'm negative. I'm not allowed to be this point down here, but I'm going to decrease all the way to 3. I have no idea if the slope continues the same or not. And I'm going to run into that 4 right there, and I'm going to put an open hole because that was not part of the domain. And there's my nice little graph, I think. It also says I'm positive at -2, 3. I'm positive from -2 to +3. That makes sense because it was above the x-axis, not including at -2 or 3. So yeah, there's the graph. There's other ones that would do. Maybe I could have put some curvature on it. I did these two average rate of change ones. Your formula for average rate of change, abbreviated ARC, because I don't want to write it, is f of b minus f of a, sitting pretty over b minus a. So I just plug in some numbers. I get my A and B from my interval. You know, last year's juniors, this year's seniors, I doubt they had a 33% success rate on average rate of change. It was bad. They were a special group of kids. In this case, the word special isn't good. God bless them. I'm going to plug in a 3, because x is 3. A 3 take away 2 is 1. 1 squared is 1. Times the -2 is -2. And -2 plus 3 is 1. Got to find f of a by plugging in a 0. So -2 times 0 minus 2 quantity squared plus 3. This is going to create a -2. A -2 squared is 4 times a -2 is -8. Add 3, I get -5. And now I can do my little formula. It's going to be f of b, which is 1, take away f of a, which is -5. Sitting pretty over b minus a, 3 minus 0. Top becomes 6, the bottom is 3, this ends up being 2. Now this one has a new letter in it, but this is still a, this is still b. So to find f of b, I'm going to let my x be an h. I don't know what h is, it's just a variable. And I end up with 2h squared plus 1, because h squared is h squared. To find f of a, I plug in a 0. And this ends up being what, 1? Because 0 squared is 0 times 2 is 0 still. I had 1 or 1. And then I use my nice little formula here. F of b, which ended up being 2h squared plus 1, take away f of a, which ended up being 1, and it's over b minus a, which is h minus 0. The 1's cancel. That should be take away 0. And that's gone too. H take away 0 is just h. And I get 2h squared over h, and I do a cancellation process. I just get 2h. Remember thinking back in algebra 1, x squared over x was just x? You can't tell me you didn't do that, because you did. Same idea here. And up next is going to be the ACT stuff. Discount tickets to a basketball tournament sell for $4 each. Enrico spent $60 on discount tickets, $37.50 than if he had bought the tickets at regular price. What was the regular price? So I'm going to figure out how many tickets he sold or he bought. So he bought 60 tickets at $4 a piece, which means he bought 15 tickets, which is important. A normal price is $37.50. Sorry, is going to be 60 plus $37.50, $97.50. So if I just take the number of tickets he bought, divide it by $97.50 by 15, I should get the price. And that's $6.50. It was like, whoa, Milbrath, you just did that in your head? Yes, I just did that in my head on the freaking calculator. Well, walking, talking calculator. I'm pretty sure that I'm somewhere on the autistic scale, possibly Asperger's. That's where you just say what you feel like saying. But I can think pretty quick. 6.5, so 650. Now, sometimes I ain't 100%, and I don't work too well, but most days I do. Here we have our FOIL technique, our double distributive property, DD property. 3x times 3x is 9x squared. 3x times 4y is going to be 12. There's an x and a y squared. Inside, negative 4y squared times 3x is going to be negative 12. There is an x and there is a y squared, so it's kind of cool. These cancel each other out. And then outside, or last, negative 4 times positive 4 is negative 16. Y squared times y squared is y to the 4th. And you may not remember this property, but, and it's on your formula quiz that you have Tuesday. I think I've got it x to the a times x to the b. We add the exponents. And 2 and 2 adds to be 4. Now the inside knocks each other out. 9x squared minus 16y to the 4th. A rectangle has an area of 32 feet and a perimeter of 24 feet. What is the shortest side? Shortest of the side lengths in feet of the rectangle. You know, when I was a kid, I always wondered why teachers wanted to do algebra and stuff like this because it was so simple. And I really don't see the point in doing algebra. I really don't. But you have a rectangle and you have a perimeter of 24 feet, and it's pretty obvious to me that that means we're going to have 4, 4, 8, and 8. Number of rectangles, 4 right angles, opposite sides are by definition congruent. And anyways, that gives you your 24 feet. And the area of a rectangle is length times width, so 4 times 8 is 32. Doing this with algebra is kind of a pain in the butt-ish. But the shortest side is going to be 4. 14, a function is defined as f of x equals negative 8x cubed. What is f of negative 3? That literally means we let the x be negative 3. Function notation is on the ACT. And if I take a negative 3 and I square it, I get a positive 9. And negative 8 times a positive 9 is negative 72. If 3 to the x is 54, then which of the following must be true? Ah, this is always fun. It's saying these x values must be stuck between something. So if this one is the case, this says that 3 to the first is less than, 3 to the first is 3, and 3 to the second is 9. 54 does not lie between 3 and 9. What you're looking for is you're looking for exponents where the answer lies. So I'm going to look at choice C. 3 cubed is 27. 3 to the 4th is 81. So yes, the actual correct answer to this is somewhere between 3 and 4. That's what this is saying. It's saying x is somewhere between 3 and 4. And we do learn how to think like this later on in the class. We do logarithms and exponential growth functions and stuff like that. The least common multiple of 70, 60, and 50. So what you're doing is you're looking for a number that all three go into. So 70 doesn't enter 60. 70 doesn't enter 180. 70 enters 210 3 times. 60 enters 210 not 3 times, 3.5 times. It's not nice. 70 enters 2100 30 times. You take 2100 and you divide it by 70, you get 30. Will 60 enter that? Yes. 60 will go into 2100. It'll go 35 times. 30 times 60 is 1800, 5 times 60 is 300. So it's looking pretty good. And will 50 enter 2100? Of course it will, because it ends in 00, for one. What are you looking at here? 42 times? Least common multiple. Hotshot Electronics is designing a packaging box for its new line of acoustical Odyssey speakers. The box is a rectangular prism of length 45 centimeters, width 30, and volume 81,000 cubic centimeters. What is the height in centimeters of the box? This is a standard straight out of 8th grade. At least it was 8th grade the last time I dealt with 8th grade, which was my student teaching days, what, eternity ago? Plus, I remember this formula. Volume of a box is length times width times height. We're going to substitute stuff in. We know the volume is 81,000. We have a length of 45. We have a width of 30, and the height is unknown. So, we're going to figure out what 45 times 30 is. It should be 1,350. And that's equal to 81,000. And all we have to do is we have to figure out how many times 1,350 goes in 81,000. And it's going to be 60. Promise you it's 60. Probably don't believe me. Let's see here. Let's just see if I'm right. Let's just do the 6. Yeah, we can go in 8100. 6 times 0 is 0. 6 times 5 is 30. Anyways, I don't even feel like doing a long division. I know it's 60. I know it's 60. So there you go. For some reason I was struggling the old long division algorithm. Oh, weird. Anyways, that should be the homework I'm going to do on that one. Looks like I'm at the end of my slides. So there you go. Enjoy it.